So a set which contains only one element. Sometimes it is written by having one element we can easily recognize. If it is given in the listed form, roster form, we can easily recognize. For example, zero, a set containing only zero or any one element, five, or containing only -7. These all are singleton set because they have only one element. But sometimes when it is given in the set builder form, then we have to check them. For example, A is a set of all x such that x plus 8 is equal to 0 and x belongs to integers. Correct. So here you can see that x plus 8, that means x will be equal to -8, and -8 belongs to the integer. So therefore this will contain only one element, that is -8. So it is also a singleton set. Correct, because it has only one singleton set. Okay. Now we'll take one more example. Let example. Let T is the set of elements such that x plus 5 over x minus 7 minus 5 is equals to 4x minus 40 divided by 13 minus x. That T is this one. The question is T a singleton set? Is T a singleton set? So justify your answer. Justify means we cannot write directly. We have to show that it has only one element. So as we have given this condition, so we have to solve this to find out whether it has one element or more elements. So for that one, we have given this. So therefore, we will solve this equation x plus 5 upon x minus 7 minus 5 is equal to 4x plus 40. We can take out common 4. So it will become x minus 10 by 13 minus x. Okay. Then we can take the LCM. Left side solve LCM x minus 7. So this will become x plus 5 and minus will multiply with minus 5x and this minus and minus plus 5 7 is 35 is equal to 4 times x minus 10 divided by 13 minus x. So 5x plus x, 6x plus 35 plus 5, 40 divided by x minus 7 is equal to 4 into x minus 10 by 13 minus x. Okay, now we can 4x minus 40. This is the x will be minus 5x plus x minus 4x. Okay, so minus 4x, if we take minus 4 common, so minus 4 common, it will become x minus 10. Correct? Here also x minus 7. And this you have to bring left hand side, minus 4 into x minus 10 upon 13 minus x is equal to 0. We should not cancel this one. We should not cancel, otherwise we will not get the two values. Sometimes we are getting two values. If we cancel, we get one value. So x minus 10, if you will take common x minus 10, or also 4, you can take common 4 also. So you are left with minus 1 upon x minus 7 minus 1 upon 13 minus x is equal to 0. Okay. And if you are taking minus common, this will become plus. You can take minus here common. This both will become plus. Okay. And take the LCM, solve it. We get LCM as minus 4 into x minus 10. This is one of the factors which can be equated to 0. These are the two factors. One factor is this one, another is this one. When you equate it to 0, x minus 10 is equal to 0, x is equal to 10. Or the second factor is x minus 7, I'm taking LCM, into 13 minus x. LCM, so this will become 13 minus x plus x minus 7 is equal to 0. But here x will cancel and this whole will become 0. There is no value effect. No value of x. So therefore only we have 10 value. Hence t is having only one value, 10. It is a singleton set, and t is a singleton set. Yes, x is equal to 10 by answer. Yes, correct. So finite set a set which is either empty or consists of a definite number of elements. Means definite number of elements. Therefore, it is finite set. Then one more thing, if it is a finite set, it will have definite number of elements. Distinct elements we are writing, and you know that in the set we are writing distinct elements. Okay. So number of distinct elements. For example, you have written a set of a word A is a set of all x, such that uh, x is a x represents the word, let's say set. Okay, letters of the word. Okay, set. So then we will write A will be equal to S E T. So how many elements it has? The number of elements of A are 3, not 4. Number of elements means this is the distinct element. So the number of elements means number of distinct elements. So always we are writing distinct element. Okay, not same. So distinct element. So this number here, this number is noted by n. So n a is equal to, here n a is equal to what? 4. What will be n b? N b will have only two numbers. X square is equal to 5. So x will be equal to plus minus 5. So this set will have the numbers only minus 5 and plus 5. So the number of elements in B is 2. And here number of elements in set A, this set A is equal to 3. So this number, this distinct number of elements in the set, it is called cardinal number. Just write down. This is called cardinal number. So cardinal number is the number of distinct elements of a set. Cardinal number. The number of distinct elements in a finite set. Distinct elements in a finite set A, any set A is called cardinal number of set A, called cardinal number of set A and denoted by NA. N is the number of elements, distinct elements. It is denoted by NA, and we have seen this example like here. The cardinal number of this set is 4, and cardinal number of set B is 2, and cardinal number of this A dash set is 3. So understood the cardinal number? The number of distinct elements. Yes. Finite set. So it will have finite number of elements. When it has finite number of elements, then only we can write the number of elements, distinct number of elements. So this cardinal number is associated with finite sets only. No question of infinite set will not have any finite number of elements. So what is infinite set? Infinite set is a set which contains finite number of elements, like set of natural numbers. A set, a set which contains infinite number of elements, which contains or consists of infinite number of elements, called an infinite set. Okay, and example, we can write many examples. A set of natural numbers. A is a set of natural numbers. Then A will have 1, 2, 3, up to infinite. So this is the example. And now we have the question. We have to find out whether the given set is finite or infinite. We have to find which of the following are finite and which are infinite sets. So set of concentric circles. It is finite or infinite? Yes. Correct. Kapra, Vipa. Infinite, because concentric circles means, what are concentric circles? Which have same center. Suppose I have taken the center point, this one is the center point, and I want to draw the circles. We can draw many number of circles. This is the one circle on this center, and the circle like this. So we can draw infinite circles. So this is an infinite set. Finite set. Okay. Then set of lines parallel to x-axis. This is x-axis, and how many lines we can draw? Set of lines parallel to x-axis. Correct. This is also correct. All of you have given correct answer. People, Afra, Dayan. Okay. So infinite set is also infinite set. Then third one, set of circles passing through origin also infinite. So it is also infinite set. What about this? A set of animals. That is the main thing. What do you say about question number 4? Set of animals. Some are saying infinite, some are saying finite. It is a finite set. It is considered to be a finite set because that contains finite number of elements. We don't know the exact number, but it is finite. So therefore, just remember that this is a finite set. So this type of question if comes, you can understand this is always a finite set. Got it? Now we have equivalent set. What are equivalent sets? Equivalent sets and equal sets are different. Equal sets are different. Okay, so equivalent sets, two sets A and B. A and B are said to be equivalent, are said to be equivalent set, if and only if their cardinal number is same. If their cardinal means if one set has four elements, another set will also have four elements, then they are called equivalent set. If their cardinal numbers are same, that is, we can say number of elements in set A and A, number of elements in set A will be equal to the number of elements in set B, then they are called equivalent set. For example, you can say that let A is a set of elements A, B, C, D, A, B, C, D, and B is the set of numbers 1, 2, 3, 4, 1, 2, 3, and 4. Then they are equivalent set. First, then we check their cardinal number. So here you can have the cardinal number and A is equal to 4, and number of elements in B is also 4. Therefore, A and B are equivalent set. Equivalent set. Okay. So we can have some question also, but we are doing equal set, then we can complete the types of set. So equal set, two sets are said to be equal. If they have exact elements, means have exactly the same elements. Obviously, the cardinal number will be same and the elements will be same. It can be written in the different order, but the elements are same, exactly same. So two sets A and B are said to be equal set if they have exactly the same element. If they have exactly the same element. Exactly same elements. It can be written in the different order. Okay. And two sets are said to be unequal. If we write A is not equal to B, we write A is not equal to B. So we write it as write it as A is equal to B. Here we cannot write A is equal to B. for equivalent set. For equal set, we can write. For example, suppose A is a set of elements A, B, C, A, B, C, and you have given another set D whose elements are C, D, B, and A. So you have to check, just check A is here, okay, A is here. Then B is here, okay, B is also here. Like this, you have to check each and every element. C, okay, C is also here one time, C is also here. Then you can see D, D is here. Yes, you can check D, D is also here. So all four elements are here, they are exactly same. Therefore, then we can say that A is equal to B. These are the two equal sets. Okay, got it? So we are left with some examples based on equivalent set and equal set. And then this topic will be finished. You can have the next.